Let's do it. I don't do a very good Arnold Schwarzenegger impersonation. Let's do it. No, what was the other one I was doing when we were hiking? I was hiking with my wife, and I was like, the one Opie and Anthony used to play. That's a good one. Is that a terrible impersonation? Well, that's right. You must have butt dialed this podcast. I don't know why else you would be here, but let's do it. Yes! Wow! This is awesome. We're back with the Podcast Engineering Show. My name's Chris Curran. I produce podcasts for the likes of E+, Dun & Bradstreet, and Forbes, and select business authors, and the amazing Laura Shin with the Unchained podcast, all about Bitcoin and cryptocurrency. Every week on this show, we bring you podcast production techniques while holding them with white gloves. Oh, that was terrible. I usually say on a silver platter, Michael, and then last session I said in a golden goblet. So I was trying to work in the white glove thing. It didn't quite fly, though, did it? Anyway, I have a background in audio engineering in the music business, and since I entered podcasting about 5 years ago, I've noticed a huge lack of audio skills, audio engineering, the fundamental skills. There's been a huge lack of it in podcasting. Not only podcasters, but also podcast producers and podcast editors. A lot of people are working in the industry of podcasting, and they really don't have a solid fundamental audio background to draw on. And sometimes you can hear it. Usually you can hear it. So if you implement the best of what you learn here on this show, your shows will sound a lot better, and you'll spend less time producing them. Today, we have a very special guest, but before I introduce our special guest, I want to just say hello to Barry. Barry, how you doing today?
Yeah, oh yeah.
Barry, is that a yes? I mean, is that a you're doing good or not?
No way. You crazy?
Oh, dude. I forget sometimes, Barry. I can only ask you yes/no questions. But you know what? What is Michael Pettersen going to need to really, pull off a really great appearance on the show? What is he going to need?
You're going to need a couple of horses or a couple of mules.
I mean, he's the director of corporate history at Shure. At Shure, I was going to say Shure Microphones, but Shure makes a lot.
Shure Incorporated.
Shure Incorporated. He's the director of corporate history. I don't think he has, horses and mules laying around. But anyway, Michael, happy to have you on the show. Welcome to this show.
Thank you, Chris.
So we're going to talk about some history, and which is fascinating, because what's the saying? You have to know where you came from in order to. I don't know the saying exactly, but knowing your history is important. Because
and interesting. You really only think it makes sense to you once you've been in the industry for a long time, and you can kind of look backwards, and then you can start to see how the pieces of the puzzle go together. What I know now, when I first started the industry in 1976, wouldn't make any sense to me because I didn't have that experience. So I think that's why most historians are old guys.
Well, you've been there and done that and seen it all, and right, you can sort of you've imbibed so much knowledge, you can sort of process it and make sense out of it, and then be able to share that. That's
exactly
awesome. And so we're going to talk about some history of microphones, and especially why it took the SM7B 35 years to become popular.
Yeah, that's a strange story.
All right, we'll start with that one, but after that we're going to talk about some microphone myths. There's a lot of things that people think about, and they think they know about microphones that aren't exactly correct.
Oh, we could spend 2 hours on just that subject by itself.
All right, we're going to do that, and I also want to just direct people to, because when I was looking up your bio online and reading some of your stuff, you wrote an article called 10 Things You Might Not Know About the SM58.
Mm-hmm, yep.
And I'm going to link to that article in the show notes of this session, so everyone knows the SM58. Well, how would you describe the SM58?
Certainly the most widely used microphone for performance in the world, and quite amazing since the microphone was introduced in 1966, and every year we sell more than the previous year. I often wonder where they're all going.
Wow, And because they're so well built too that they don't go bad.
Right. You'd be interested to see the SM58s we have in the Shure archives here that have been dropped, run over, burnt, all kinds of different things. And we just keep them because they still work. In fact, for us, if we find an SM58 that doesn't work, we're actually kind of surprised.
You're right.
What went on there?
Got to dissect it and figure out what happened.
Yeah, we actually do that. We actually have X-ray machines and all kinds of ways here to look at things and figure out what happened. We actually do drop tests on them and record it in high-speed motion and high-speed video so we can see what's happening at the point of impact.
Oh, wow. That is cool.
Yeah.
Actually, one of my friends from high school does that too, like the high-speed photography, and he was working for a while when they crash the cars and they film it at like 1 million frames per second, and then they can like dissect everything. That's awesome.
You brought up an interesting point. So you know how cars have crumple zones, right? So that when there's an impact, the part crumples and takes most of the energy.
Right.
The SM58's got that too, and that's why the grill dents.
Really?
Mm-hmm.
Oh, I mean, how many stages have I been on where you look at the vocal mic and it's a SM58 and it's like completely dented, but it doesn't matter. It still sounds fine.
Right. But that grill is made malleable like that so that when you do drop it and it hits the grill dents and that absorbs a lot of the energy that otherwise would have been transferred inside the mic.
Right. Jeez. So let's get into let's talk about the SM7B first, because I think that is a very popular podcasting mic.
Indeed.
And I just even ran a poll on Twitter, and most people said the SM7B. And it's a great mic. I have one. I used one for a long time, and I still use it from time to time. But you said it was around for so long before it really became popular?
Well, take a guess. What year was it introduced? Just your best guess.
I don't know. I would say maybe the 80s or
1973.
73.
And we had aimed it at the voiceover work for radio and TV. You know, the WG in Chicago. You know, that type of guy, right?
Right.
And from 1973 up to around 2008, it did okay. Sold about the same every year, a little more, a little less, just kind of flat. Not what we would call a great performer, but, good enough to keep in the line. And in 2008, there was someone who did a podcast, and I can't tell you it is, you probably would know, but someone who was fairly new in podcasting or was like, a pioneer in podcasting, wrote about what a great microphone it is for podcasting. And within a year, we were selling, within 1 month, what we were selling the previous year. It was just amazing, and it's gone up from there. So that's a microphone that literally, we laugh about it. It took 35 years to take off.
Yeah, and it's interesting. I was going to ask you if the reason was podcasting, but
yes,
it clearly was. That's awesome.
Absolutely. No doubt about that. Because, the number of TV stations didn't increase, the number of radio stations didn't increase. So it had to be something else. I mean, home recording as well. So that was one boost. There was another boost when the SM7 was used for all the vocals on the Michael Jackson Thriller album, which is, of course, a classic from the 80s. And when that information came out, there was a bump there, but that, eventually everybody had them for their home studio, and it kind of fell off. But the thing for podcasting, man, that's just grown from 2008 and continues to grow. So that's now a really great seller for us.
That's interesting. I didn't know that about the Michael Jackson Thriller album. It was all his vocals were through a SM7B?
Yep. It would have been an SM7 there. There was an SM7A. Original was the SM7. SM7A added a humbucking coil inside of it, and that was necessary because in the 80s, radio stations started using video monitors to have the what they were going to talk about, their scripts on screen. And the original SM7, when you got it close to certain video monitors, it would hum and buzz.
Oh.
So we added what's called a humbucking coil, and that was the A version. And then the B version came along, I don't remember exactly, Chris, but it's probably in the late 90s or early 2000s. And then we added the big, large windscreen. So when you buy an SM7B now, you get a large windscreen and a small windscreen. And that large windscreen was added primarily because radio disc jockeys like a big windscreen.
Right. And I when I used mine, which, I still sometimes use it, but I never use it with the big windscreen. I use it with the smaller windscreen. And I think most people do.
Yeah.
But I've noticed when you talk just with the smaller windscreen, when you talk straight into it, you can pop any kind of P's you want, and it doesn't distort at all. It just it really catches them all.
Primarily because the actual diaphragm, the part that moves when you talk, is set back in that. If you take the windscreen off, you can see that the diaphragm is set back from the end of the grill probably about 2 inches, maybe 3 inches, and that's part of the reason. And another thing, though, if you never want to pop a microphone at all, ever, just have it pointed at the corner of your mouth rather than pointed at underneath your nose. If you go back and you look at, like, Frank Sinatra singing, you notice he kind of always held the mic off at the corner of his mouth. That's because you can't pop it at the corner of your mouth.
Yeah, because the air from the P comes straight out of your mouth. So if you
That's exactly right. Yeah.
And it's funny, you can grab microphones, and I when I teach a little bit about microphone technique, you can do this. It's like you can have someone use a microphone and then pop the P's and then just move it off, angle it off a little. Like when you hold it in your own hand and you're popping P's and everything, then you can really sort of figure out what angle and how far away to hold it. It's pretty cool.
Yeah. I always tell people, if you want to see how to use a microphone live, go back and look at Frank Sinatra or Ella Fitzgerald, because they really developed, the art of how to work a microphone, as they say. But a lot of people won't go look at those things. They stick it underneath their nose, and they hear popping and they hear breathing, and they wonder why.
Right. Hey, when you mentioned the Michael Jackson thing, I remembered I worked on a Helmet record called Betty, and the singer, Paige Hamilton, he was for the vocals on one song, he wanted a distorted vocal. So he literally had an SM58, and he literally, had it, he was right on top of it. It just literally holding it in his hands. It wasn't even on a mic stand. He was holding it in his hands, kind of moving around the room a little, and just pretty much screaming into this mic. Came out good though.
Yeah,
for what it was meant to be.
It really is unlikely, almost impossible that he was actually distorting the microphone, because really to distort a dynamic microphone, you actually have to force it with so much air pressure level that the diaphragm will bottom out against the magnetic structure, and that basically takes like a Saturn V rocket lifting off. But what happens is that you can scream loud enough into the microphone where the signal coming out of it will clip or distort the device you're plugging it into. So he was probably clipping the device he was plugging it into.
Yeah, definitely was. We were overdriving a mic pre, and that's where the distortion was coming from. Yep. And just to clarify, that was an SM58. I know we were just talking about the SM7B, and I kind of switched it.
Well, I'll tell you another interesting story. The SM7B, the SM58, the SM57, and then the discontinued SM56, which has been gone a long time, they're essentially what we call the Unidyne 3 capsule, and the acoustical design of them are basically all the same.
So the element of it is the same.
Yeah, the internal engine, if you will. So like an SM7 and an SM57 are like, nearly identical twins, but there are a few changes on there. But the primary difference is that the SM7 has a large rear acoustical chamber. There's a larger acoustical space behind the diaphragm, and that helps to extend the low end. Oh,
that's interesting.
Yeah.
All right, so let's go back. Let's go back in the Wayback Machine. How old is Shure Incorporated?
Founded in 1925, one-man operation. Originally, it was a radio parts company. Mr. Shure graduated from the University of Chicago, and he had a degree in geography. And much like people graduating with a degree in geography now, he had a hard time getting a job.
Right.
So after a couple of years, he went to his dad, and his dad was a partner in a very successful catalog company, kind of like a Sears catalog, but designed for wholesalers instead of like the end user. And he came to his dad and he said, I want to start a catalog company, kind of like what you run, but I want it to sell radio parts. And in the early 20s, radio was kind of like the new technology, like computers were 30, 40 years ago, and you actually had to build them. So he was selling the cabinets and the loudspeakers and the tubes and everything else. And basically, you got this catalog from the Shure Radio Company, and you decided what parts you wanted, ordered those parts up, and then you built your own radio at home. So that's how we started.
Wow. And so it was radio parts, and then did that include microphones right from the start?
Nope. That's a good question. So the short version of it is, in 1928, his brother, S.J. Shure, joined, and then we became Shure Brothers. And a lot of people knew us as Shure Brothers. In fact, we kept the Shure Brothers name from around 1930 to 2000. But what a lot of people didn't know is that by 1930, Mr. Shure, S.N. Shure, the founder of our company, had to let his brother go because of the Depression.
Oh.
But, okay, his brother went down to St. Louis, started his own very successful company making heating and air conditioning equipment. So his brother did just fine. But by 1930 and 31, there was the Depression, so people weren't buying radio kits, and you could buy pre-made radios off the shelf from the version of Best Buy or whatever it was back then.
Right.
So Mr. Shure said, I better find another business to get into. What he found was that he started looking around, and he started looking at new technologies. Now, it's hard for us to imagine this 80 years later, but these are new technologies in the 30s. Public address systems were relatively new. Two-way radio, for police and fire was new. Ways to record sound onto discs was relatively new. You could do it acoustically, but now you could do it electronically starting in the 20s and the 30s. And also, of course, radio stations. So the common element here, they all used microphones. So he was not an engineer himself, and he didn't have any engineers working for him, but he found a company just outside of Chicago in a suburb called Berwyn, and it was a company called the Ellis Electrical Laboratories. And they made a really nice carbon microphone. Mr. Ellis at the time was probably in his 60s. Mr. Shure was in his 20s. They met, and Mr. Shure asked Mr. Ellis, how many microphones did you sell last year? And I think Mr. Ellis answered 10.
Oh, boy.
And Mr. Shure said, well, if you had distribution around the country, could you do more? And Mr. Ellis said yes. And so Mr. Shure said, I tell you what, if you let me be the exclusive distributor of Ellis microphones, I will guarantee you I'll buy 100 microphones a year. So actually, we started out not as a manufacturer, but as a distributor.
Oh.
And then a couple of years later, Mr. Shure said, I think I could make these even better. And then he decided to hire some engineers and become his own manufacturer. But originally, we were doing a distribution.
Wow. And a carbon microphone, that's like now we have dynamic and condensers, right? Carbon is a completely different kind of mic.
Completely different element. Not many use it anymore, but I got to tell you about carbon microphones. These things are indestructible. You think an SM58 is indestructible. Carbon microphones are almost completely indestructible.
Wow.
You'll still find them sometimes on things like coal mining operations, on offshore drilling rigs, on older telephones. You go back and you see a telephone from the 50s or 60s, where you can unscrew where the mouthpiece is and there's an element in there. That's a carbon microphone. They're very, very durable, and the only downside to them essentially is that now you'd have a hard time actually finding the carbon granules that are in there, and they're a little bit noisy. But durability, man, hard to beat them.
Right. So then he got some engineers. He started making his own microphones, and basically just kept improving on that up until now, right?
Yeah. The first microphones were carbon. The second microphone we brought out was a condenser microphone, which is really unusual because people think that we didn't get into condenser microphones until the late 70s with the SM81, and it turned out that our first condenser was actually 1933. Huh. And then we also made crystal microphones. Now, crystals are interesting. Those are no longer made to my knowledge. Very unique thing. There's a material called the Rochelle salt, and it's a type of crystal. And it's a type of salt crystal that you can actually grow. And then you take these crystals, or this hunk of Rochelle salt that you grow, and you slice off a really thin piece of it, thin enough where it can be flexible. And you hold down one end, and you flex the other end, and it actually produces a signal. Huh. And so the crystal microphones were, they were probably 1930s, 40s, 50s. By the 60s, most of them were gone. And, of course, our big breakthrough was in 1939 when we brought out the Unidyne microphone. Sometimes people call it the Elvis microphone, the one that looks like a bird cage or the front of an Art Deco car.
Yeah.
And that was the microphone that put us on the map. And that microphone, believe it or not, Chris, we first introduced it in 1939. We still make it now in 2017.
With the same pieces and parts?
Not exactly. They have the same. It has the same exterior look, right?
Uh-huh.
different magnets. Things change. Adhesives change, plastics change, and so forth. But you're right about one thing. The acoustical design, the acoustical network that's inside of it that makes it sound like it does and makes it directional is essentially the same.
Okay. That's a dynamic mic?
It's a dynamic mic, yep.
Okay. And so, wow, so that Elvis mic, that's what's the actual name of it?
Well, it was the original. It was originally the Model 55. We call it the Unidyne, Unidyne. So the large version that you see often with Elvis was the Unidyne 1. In 1951, we brought out the Unidyne 2, which is called the 55S. S simply stands for small because it was smaller. Mm. And it's the smaller version that we make today. We did make in 2014, which is the 75th anniversary of the Unidyne 1, we brought out a limited edition of the larger model. And but we don't make the larger model now, it's just a smaller model. But that's the microphone that, if it hadn't been invented, I wouldn't be talking to you right now, and Shure may not even exist.
Right. So now when Elvis used it, I mean, there was no windscreen or pop filter. Was that a mic that could get popped?
Yeah, but he was actually pretty good. If you go back and look at the old Elvis things, he was pretty good about that. It was, at the time, the microphone that would allow you to be the loudest on stage. Because, rock and roll was just starting to grow in the 50s, and they wanted it louder and louder. And so what they were looking at is what microphones will perform, could be turned up the loudest on stage without feeding back. And the Unidyne was the one that they usually chose.
Oh, that's interesting. So that brings up a good question about the microphone output. I think, most people never think about the fact that the microphone is converting the changes in air pressure into an electrical signal, but then that electrical signal comes out of the mic at a certain strength.
Yep,
some mics,
absolutely correct. You're correct.
Some mics output it a little stronger than others. And actually, one thing with the SM7B in the podcasting world, a phrase that everyone uses with the SM7B is that it's gain hungry, that it's a little difficult to plug it into a really crappy mic pre, because then you have to crank it up all the way, and then of course if it's a crappy mic pre, it's gonna sound bad, not because of the mic, because of the mic pre itself.
Absolutely.
So what the output level of a mic? How is that determined?
Well, let's look at the output level of a dynamic, because it's simpler. Okay.
Okay.
There's basically two things that you can do, easy things you could do. You can make it have a stronger magnet. Stronger magnet usually means a bigger magnet. Of course, that adds weight. So you can change the magnetic field, if you will. This is the strength of that. And you can change the amount of turns on the voice coil, and the voice coil is attached to the diaphragm. But if you put too many turns of wire on that, then the voice coil gets heavy and doesn't respond as well. So it's really kind of a very sensitive balance, right? You want to look at the number of turns, the size of the wire, and so forth. So that's about the only things you can do in a dynamic microphone. And there was some breakthroughs in magnets. So the first breakthrough was called the Alnico magnet, ALNICO, which is aluminum, nickel, cobalt. And that was a manufactured magnet, and that had a stronger magnetic field than a typical magnet you dig up from the ground. So that allowed you to have a stronger output microphone because the Alnico magnet had a stronger field. And then in the 80s, I think it was, there's something called neodymium. You ever seen that name?
Yes.
Yeah, neodymium magnet. That was a breakthrough that came from General Motors. And again, all it did was same size magnet, but the materials that made it up gave you a stronger magnetic field. And so then the neodymium magnet replaced the Alnico in a lot of microphones. People used to do it. They would take a microphone A and microphone B, and one had a neodymium magnet, one had an Alnico, and the one with the neodymium would just be louder because it had a stronger output level. But no matter what, you can still only get X amount out of it, just because physics gets in the way. So with a dynamic microphone, your signal levels are all going to be about the same. You can look at Shure microphones and Sennheiser microphones and look at dynamics. You can see that the output levels are all about the same because it's physics. Not going to change those aspects of it.
Right.
Condenser microphones, on the other hand, you can build electronics into it. And with electronics, you can add amplification.
And that's why condensers need phantom power, right?
Well, part of the reason, yes, it does that, but condensers need phantom power for some other things as well. Number one, there is at the actual condenser microphone element itself, there's what's called an FET, a field effect transistor. and that basically is an impedance converter. If you look at the impedance of the actual condenser element right at the element, it's millions of ohms, really, really high impedance. And that means it's not going to travel down the wire very far, maybe a couple inches or so. So the first thing you got to do with a condenser microphone is convert that really high impedance down to something around 3,000, 4,000 ohms. And that's what the FET does. So that's number one, the reason you got to have phantom power is to power up that FET. Now that you've converted it to around 3,000 ohms, now you have to balance it. You have to turn it from an unbalanced signal into a balanced signal, and that's what the electronics do inside of a microphone as well. So phantom power, you can say this, phantom power is necessary to power up the electronics inside of the condenser, but what the electronics doing are several things.
Got it. And those electronics within a condenser mic, you as the manufacturer can tweak that to make the output level a little stronger or weaker or whatever.
Right. So if you look at condenser microphones, their output level go all over the board. They can be 15, 20 dB apart from each other, and that's because you can tweak the electronics. Of course, what you're trying to do is when you increase the gain, you're trying not to bring up the hiss level. So when you see these, as you said, these cheaper mic preamps, they're assuming that you're going to put in a condenser mic, which has already got some of the gain built inside of it.
Right.
And so people make the wrong assumption that, oh, that worked good with my cheap condenser mic, which had a lot of gain in it. I'm going to plug the SM7 into it. And now then they say, uh-oh, it's not loud enough.
Right. All right. Now, what about these, I'm thinking of the classic vocal mics, large diaphragm condensers that had a separate power supply. So you'd plug the mic into this, it's like a box, like almost like a small shoebox sometimes that big. And then, so what is that box doing?
Well, originally, condenser microphones themselves, we have to go back to what we call a true condenser. I'm going to try not to get too complicated here.
Go for it.
But a condenser microphone is basically, let's talk about the parts of the condenser microphone. First of all, there's actually the diaphragm. And that's a piece of plastic. Let's say it's about the size of a quarter or a $50 or whatever like that. And on that is a little fine coating of gold. If you actually came to Shure and went to where we manufacture our condenser microphones, you will find that we actually buy sheets of gold leaf that we can basically, it's called sputtering, where they actually take this gold leaf and they literally put on a very, very thin coating of gold onto the back of this plastic diaphragm. And that makes the diaphragm conductive. Then there's a little airspace, and the airspace behind that condenser element is probably 10,000ths of an inch. Oof. And then back behind that is what's called the backplate, and the backplate has a voltage on it. Now, today, most condenser microphones are called electrets, and that means that in the early 60s, a guy at Bell Labs, a couple guys at Bell Labs, figured out a way to take Teflon, of all things, and create a backplate that was permanently charged. They would take this Teflon-like material, hook it up to 100 volts or 200 volts or whatever it was, leave it on there for a day or whatever, and when they took it off, it kept the charge, which is pretty cool, right?
Right.
It's kind of like a permanently charged battery.
Yeah.
But before electrets, that backplate had to be charged up by that power supply that you were just talking about.
Oh. That's interesting. And then, so when the air, or the difference in air pressure, technically, I guess, when that hits the gold foil, it vibrates that, right?
Right. And then that little airspace I just told you about, 10,000 of an inch, it varies by literally microns. It doesn't hardly, you can't see it by the air, so you're actually changing the capacitance there, and by changing that capacitance, that translates into an audio signal. It's really hard to explain, in words. Certainly something that your listeners can go and look up and say, how does a condenser microphone work? Interestingly enough, condenser is actually an old word for capacitor. So if we were starting all over again, we would probably call them capacitor microphones rather than condenser microphones.
Wow.
But condenser microphone was the term that was used in the 20s and 30s before capacitor became common. So capacitor equals condenser, condenser equals capacitor.
That's interesting. Wow.
Yep.
All right, so now these big power supplies for these big, large diaphragm condensers, what are they doing?
As far as the power supplies for that, they would, they were like 48 volts. They would send voltage down the cable, And they would do two things. First of all, they would power up that back plate. This was before electrets, and they would power it up to maybe 100 volts or 200 volts. And then they would also, that power supply would also run electronics that were sometimes in the mic capsule, but sometimes they weren't, and sometimes they were actually in that big box that you looked at. So if you go back and look at mics from the 50s, typically that power supply was located relatively close to the actual microphone itself. But that made condensers expensive, couldn't make them small. And so when Bell Labs invented this electret in the early 60s, that changed everything, because now all of a sudden the prices for condenser microphones dropped dramatically, and you could make them smaller. And electrets at first had a bad rap because originally they weren't reliable. Those back plates I told you that would charge up, some of them would fail and so forth. In fact, here's the interesting thing. You ever notice how sometimes on TV the news anchor has got double mics on them?
Yeah.
Okay, that all goes back to the 70s when Sony first brought out these small electret condensers, and they failed so often that they started double miking people.
Right?
Right. Today, probably don't need to do it, but it's just we're kind of stuck with it, right?
Wow.
And they say, so let's double mic everything. But then electrets got more and more reliable, and today they're incredibly reliable. And the need for a quote-unquote true condenser microphone, which is a non-electret condenser microphone, pretty much has dropped away.
So in the 60s, which some consider to be like the heyday of, analog recording equipment in the music studios and all this kind of stuff, what Shure mics were in the studios at that time? I mean, I guess the SM57 was there.
Well, 57 was not introduced in 1965.
Oh, it was introduced in 65. Okay.
Right. So really, in the early 60s, most of the recording microphones that were in studios were probably Neumanns.
Okay.
Great mics, German microphones. We weren't really that established. I do know that at Sun Studios in Memphis, which is where Elvis recorded and Johnny Cash and so forth, they used a Unidyne Model 55, the large model. In fact, you can go down to Sun Studios even today, and they've got the microphone there, and you can sing into it, which is kind of cool.
The same exact mic.
Yeah, exactly. But I would say, in the early 60s, you could have probably found Shure Unidynes in recording studios. You might find one or two of our ribbon mics because we started introducing ribbon mics in the 1950s.
Okay.
And maybe a 545, which is actually kind of the kissing cousin of an SM57.
All right, let's talk about. I want to ask you about the SM81, which you said came out in the 70s.
1978.
Okay, SM81. But first, you mentioned ribbon mics. I wanted to ask you about this. Like, I always hear great things about ribbon mics. I don't think I have one, but just how does a ribbon mic work?
It's basically a variation on a dynamic mic. So let's go back to the SM58 or any other dynamic mic. You got basically three parts. You got the diaphragm, right, which is the round piece of plastic size of a dime, size of a quarter. You got a voice coil, which is glued on the back of that, and then that sits in the middle of a magnetic structure. So when I blow air at that diaphragm, it's plastic, it can't move, and it makes and the diaphragm, by the way, is kind of suspended like a trampoline. So it bounces up and down, millionths of an inch, by the way. It bounces up and down as air hits it. Now, a ribbon microphone is basically it's a variation on a dynamic. It has a magnetic structure, but then it's got a small ribbon, and that ribbon is a piece of usually aluminum that's corrugated, kind of like an accordion that's corrugated, and it's stretched. And what happens is that the aluminum ribbon, of course, conducts electricity, but it's also flat and will move. So literally, that ribbon takes the place of the voice coil and the diaphragm in like an SM58.
Oh.
So the ribbon microphones have been around. They were first introduced in the late 30s by RCA, I believe, and they sound really great. Really a lot of low end. Very, very mellow sounding. If you want something that's bright sounding, you don't choose a ribbon microphone. If you want something that's like full sounding and you really want to sound like an FM announcer, that's what a ribbon mic does. Downside to the ribbons is that their output levels are very low. And for years and years, the ribbons were really, really fragile. They would stretch because it's a little thin piece of aluminum. And if, for example, you you tested the microphone going, like blowing into it,
Yeah.
that would often stretch the ribbon.
Oh.
And in fact, if you look at almost every ribbon microphone that's out there from the 30s and the 40s and so forth, there are no large holes on it. It's all these little tiny holes in the grill, and that's to break up any blast of air that's coming in there. So for years, ribbons were seen as being relatively fragile because of the fact that ribbons could stretch so much.
Right.
So about I don't know, I can't remember how many years ago, probably about 10 years ago now, Shure reintroduced these ribbon microphones. We actually bought the technology and the designs from a company called Crowley and Tripp, no longer in business. And they had developed a very interesting material that they call Roswellite, like Roswell, New Mexico, right?
Cool.
Funny name. But they had developed it for medical transducers, and the guy who ran the company was also interested in microphones because he was a musician, and he formed this Roswellite material into a ribbon and basically made some really pretty good ribbon microphones. The thing that was cool about Roswellite is that the fact that you can just abuse it like an SM58 and it doesn't stretch. And so we got back into the ribbon microphone business because of the fact that now we could offer a ribbon microphone that you could treat like an SM58 and you couldn't hurt it. So that's kind of the cool thing about that. And the Roswellite is like a trade secret. We don't tell people how we make it and what it's made out of, just because it was just like one of those things where you saw it, you just said, "Oh, that's cool."
Yeah, I know. So what model mic is that?
Let's see, that is a KSM 313 is the lesser expensive one, and the KSM 333 is the more expensive one. I mean, the 333 is like, God, I don't know how much money it is. I think it's like $3,000. And just, I don't work in sales anymore. Let me just check on the model numbers. Let's see, KSM 313/NE, and then the bigger one is the KSM 353/ED. So those are the two that we offer. They're great sounding mics. I mean, but they're expensive. I mean, I think they both, the lesser expensive one is still around $1,200, $1,500. The other one's closer to $3,000.
And what are they mainly used for? They're just vocal mics?
They're used for a variety of things. When Steve Martin was traveling around with his bluegrass band, he actually used the 313 on the banjo. It sounded great.
Oh, wow.
But I would say, as a rule, probably use on brass a lot to kind of take the edge off. Certainly, it can be used on vocals. They can be used on violins and banjos to kind of take the edge off. It's kind of like if you have something that's just too bright, ribbons are a really nice way to still pick up the quality of the instrument, but kind of round off the edges, for lack of a better term.
That's interesting. All right, so now let's get to the SM81. I was trying to think of a way to describe the shape of that. It's kind of like a handheld, but it's skinny, I guess, right?
Yeah, yep. It's what we call a probe mic because it's an end fire. It's probably about 8 inches long, probably.
Right.
And we had decided we had gotten out of the condenser microphone business in the 30s because you have to understand something about Mr. Shure. The company was his last name, Shure, and he was very proud of that. And if our products that we made could not be really reliable and something he was proud of, he didn't want to make it. So the condenser microphones that we made in the 30s, they sounded good, but they were really, really fragile. And he just said, I don't want to be making something that people are going to break easily. So we got out of the business, and we got out of the condenser microphone business for the latter part of the 30s and the 40s and the 50s and the 60s. And in the 70s, this technology that we were talking about, the Electret, had really come to fruition and mature. And the engineers said, Mr. Shure, we can make a condenser microphone now that you can go through all the drop tests and all the torture tests that the SM58 can do, and it will survive. And then he said, okay, we can do that.
Right.
So we brought out that SM81 in 1978, and I'm so old, I was there at the trade show when we introduced it.
That's
but
awesome.
But that thing still sells. I mean, that was coming up on 40 years now, and it still is a great seller for us.
Right.
And
I don't know if any podcasters use it, although I have heard seen some people online say they like that mic, unless I'm confusing it with another one. But I remember in the music studios, definitely for acoustic guitar, I think we recorded.
Oh yeah, great acoustic guitar. There's a really well-known classical music station here in Chicago called WFMT. You can hear it around the world online. And for years, and they still do it, their on-air announcer microphones are SM81s.
Really?
Yeah. Now, they use a really big windscreen on it. It's a windscreen that we make called an A81WS that kind of looks like a gray, but the size of a Nerf football.
Wow.
And it fits on there and does a fabulous job of preventing the pea popping.
Right.
But it's a really unique, rich sounding voice or voiceover microphone. Now you got to have a good voice in the first place.
Right.
So what's interesting was about last November, WFMT is located, I don't know, probably about 5 miles from where I sit right now here in Chicago. And they wanted to try some different microphones. They're thinking that we've been using this SM81 for a long time. You know, could we come over and do some blind testing of some new microphones? So I said, sure. So they brought 5 of the announcers over here to Shure. We have a nice recording studio here at Shure. And we set up their 5 announcers, and we set up, I think, 4 or 5 Shure mics and also an AKG mic, and had them all read, right? And then I delivered the files to them about a week later, but all I said was mic A, B, C, D, and E. I didn't tell them what. And they listened to them, and they argued about it, and they came back after, a couple of weeks, and they said, here, we like microphone B. And I said, yep, that's the SM81.
Wow. That's great.
Yeah, so they basically chose what they've been using all these years. Now, maybe, Chris, it was because that's what they're used to. But I got to tell you, I was in the listening test, and I thought they sounded best on that microphone.
Nice. And WFMT, isn't that where Mary Mazurek works?
Yes, exactly. I know Mary. You know Mary, too?
Yes. Well, that's how you and I got hooked up, actually.
That's right. That's where Mary works.
Yeah. So...
You can ask her about the famous voiceover microphone test.
I will. Hey, Barry, you remember Mary Mazurek, right? She was on the show twice. She killed it, right?
Yeah. Oh, yeah.
Yeah. Oh, yeah. So, right, the SM80. That's interesting. Now I want to see the windscreen that's about the size of a Nerf football.
Yep. You know where else you can see it? No, not anymore. Well, before the current administration took over in Washington, when you would see Obama and Bush and so forth, sometimes that's 2 SM57s on the lectern.
Yeah.
And sometimes in high winds and so forth, they would have a fairly large gray windscreen over that. That's the A81WS.
Oh, wow.
Yeah. So you can ask Mary about that. It's really, and FMT is just kind of, they've gotten used to that. And when you tune in, you dial across the station, their station sounds different than others. And I happen to think it's a nice sound.
Nice. And you bring up the 57s and the president, and I think there's a rumor, or I don't know if it's true, that I've heard that the SM57, it's been that's been the president's microphone forever or something?
Well, we didn't discuss this before we did this interview, but since 1990, I've been kind of the interface between Shure and the White House.
Really?
So I actually wrote a history book, an internal Shure history book about the presidential microphone and how it became the presidential microphone. And you are correct. It has been used on the presidential lectern since 1966 with Lyndon B. Johnson.
Wow. And so what's the name of your book that you wrote?
Well, it's an internal book. It's a Shure book.
Oh, okay.
It's something we wrote for the associates, essentially. Okay. And I wish I could give you a copy, but then they'd fire me.
Yeah, it's one of those things.
Right. But so it goes all the way back to Lyndon Johnson. It's kind of interesting about, first of all, they started out with 2 mics, but on left and right, and then we told, I was still in grade school then, but they said, well, that's not good. You really want the microphones in the middle. So they went to 4 microphones, because some general said, well, if I've got 2, I want 4. So really, there was 4, and then they finally got it down to 3. For a long time, there was 3 in a triangle. So if you look at let me think here for a second. If you look at Nixon, Ford, Carter, Reagan, and the first part of the Bush, number 1, there were 3 microphones there. And this is a funny story. They were in a little triangle. So go back, just do a Google image search. Look at Reagan and microphones. You'll see 3 microphones, 3 SM57s. And there were 3 because 1 fed public address, one fed broadcasting, and one fed recordings for the National Archive. Okay, so three separate signal paths. They didn't have to worry if one failed; they could switch around. But that was the way they did it. But there's a great story about George Bush, the first George Bush. Was a tall guy. I think he was maybe like 6'4", 6'5", and they were doing a rose garden thing at the White House, and they had the Queen of England there, who's short. She's like maybe 5'2" or 5'3". So they build the lectern, the presidential lectern, which has the seal and the typical one you see, which is kind of grayish and big. They build that in height to match the president. Right. So someone was told, okay, now when the Queen comes up, make sure you put this little stool so she can be approximately the height of the president. Right. They forgot.
Oh.
And the Queen comes up there, and all you see is a hat with 3 big microphones where her nose should be.
Oh, no.
And the British press went crazy about how could this happen to our Queen and so forth. So literally the next day I get a call, and the White House, it's called the White House Communications Agency, because that's the military organization that supports the White House for audio and video and photography. And they said, the White House wants to do something. We got to get rid of that middle mic. So literally what we did here is we took the triple mount microphone, the actual triple mount that held the 3 microphones, and we sawed off the middle one, and we sent it to them. And then in the later part of Bush 1 and also Clinton and Bush 2 and Obama, you'll see 2 microphones side by side, and that's the reason.
Wow.
Yep.
That's a great story.
Yeah. And you can't make up stuff like that.
Oh, that is great. I want to see that video now, too.
Oh yeah, if you just do Google images on like George Bush, Queen Elizabeth, Rose Garden or something like that, and you'll see at least one shot where she's got this little pink hat, and in place of her face are 3 Shure SM57s.
That's great. All right, well let's move along to microphone. Well, let me ask you before we move on, as far as the history of microphones and also specifically Shure microphones, was there any other like after the 70s, let's say, was there any other big breakthrough that Shure had?
Well, I would say small innovations. For your audience, probably the biggest breakthrough that we've had was a microphone we introduced relatively recently. And I'm leaving wireless out of this, by the way, because wireless is a whole nother subject. Okay,
got it.
So we'll just talk about wired mics.
Right.
A couple of years ago, we brought out what's called the KSM-8, and this was really probably the first breakthrough in dynamic microphones in maybe decades. And it was because customers, they said to us, look, we really like the SM58 a lot, and we knew that because of the sales, but for some singers I've got, when they get up close to it, there's just too much proximity effect. And for your listeners, proximity effect is when a singer really gets up close to the microphone and the bass gets boosted a lot more than the high end does. So and for some people they say, oh, that sounds warm, and other people can say it sounds muddy. So what customers wanted from us is they wanted the SM58 quality and reliability, but they wanted it with less proximity effect. And that's much harder than you might imagine as far as being able to do that.
I was going to say, how do you just take out the proximity effect?
Well, you can't really take it out. You basically have to redesign the whole acoustical network. And the KSM-8, there's actually some papers written on it. It basically has a secondary diaphragm. Again, very, very hard to explain to your customers, to your listeners. But essentially, by putting this second diaphragm, which is really passive and is not hooked up to the actual voice coil, you can control the low end. This took us probably about 7 or 8 years to figure out how to do it.
Oh, wow.
Yeah, it took a long time. That's a little side note. Shure has always been privately held. In other words, we don't have public stock and so forth. And because of that, you don't have the Wall Street and stockholders saying, how come I don't have any profits? How come you're working on this for so long? So this allows us really the luxury of being able to work on things for years and years and years and bring them out and really best our competitors who are not in that same fortunate situation as ours. Mm-hmm. So this KSM-8 was really a big breakthrough, and you'll see it now used a lot by high-end tourings and so forth. That was a breakthrough, and then the other breakthrough is into something that's called microphone arrays, which is not going to really interest your listeners, but essentially putting together 60, 70, 80, 90 tiny microphones and then having them form beams. This is mostly useful for like boardrooms and so forth. That's another big breakthrough.
Oh, so it like cuts down feedback and does all kinds of other cool things.
What it really does is it reduces the background noise because the microphone beam itself, the pickup area is so small. It's small, so narrow is the best way I think about it. You can read, if you just do a Google search on microphone arrays, it'll give you an idea of stuff like that. But again, that doesn't really specifically go to your customers. But that's another big area that we're working on for conferencing rooms and so forth.
Got it. That's pretty fascinating. The other thing I was looking at recently too is these virtual reality microphones that actually have 4 or more. It's like one mic, but with 4 different mics pointing in different directions, and then it's all kind of mapped onto the orientation of the mic itself. So when the mic changes, and it seems pretty cool because apparently when you record audio with mics like that for virtual reality, if you're wearing a virtual reality headset, like think about it, you're looking straight ahead, and let's say you turn to the left, and you see what's on the left, but with these cool mics now, let's say there's a sound on your left, right? So you're looking straight, the sound is on your left, and you hear the sound on your left, and you turn to face the sound. Now the sound's going to be in front of you perceptually.
Right. Yep. There's something called binaural recording, which I've always been a big fan of, and considering that everybody wears earphones these days, or most people do, I can never figure out why binaural recording has never taken off. So binaural is you basically have what's called an artificial head. It's about the size of a human head, and it's usually made of texture that kind of is like the human skin, and it has ears and antennas, which are your ear flaps shaped, and then you have basically a microphone in your left in the left channel or the left channel of the left ear and one in the right ear. And when you listen to a good binaural recording played back over earphones, you are like in the room. First time I'd ever heard a binaural recording, gosh, it was probably in the 80s, and I was at this conference, the Acoustical Society of America, and there was a consultant who was talking, a guy named Chris Jaffe, and he was showing how they use binaural recordings to basically go into an auditorium that they just designed or whatever, and make a recording, and then be able to listen to it back in their offices like they were there. So I remember, he set this thing up, and you could go and you could hear a demonstration of binaural recording. So I'm listening to this thing, and I turn around to tell the guy behind me to shut up, and there's nobody there.
Wow. That's cool.
And so I've always been interested about why someone, Shure or one of our competitors, never brought out a low-cost binaural head, because I would think that would just be unbelievable for doing podcasts or anything that you wanted to listen to. Now, the downside is that you have to listen to it on earphones or headphones. A binaural recording heard through loudspeakers sounds really, really funny.
Right.
But over earphones, man, it is just so realistic you can hardly believe it.
It's fascinating. I don't know, the next 10, 20 years. Well, the next 10, 20 years are always fascinating, but it's going to be great.
Well, let me just jump back in history for a second. The actual one of the first documented binaural recordings or binaural setups was in 1881 with the Paris Opera.
Oh my God!
This guy named Eder, Eder, set up at the Paris Opera a bank of microphones on the stage. By the way, they were called transmitters back then. The word microphone was not being used for what we call as a microphone today because it transmitted the sound. Right. So it was a bank of transmitters on the left side of the Paris Opera and a bank of transmitters on the right side of the Paris Opera. And then these signals were sent about 2 miles to an exhibition hall where you could come in and put on a set of earphones and listen like you were at the opera. Wow. And that was an early type of, I don't know if binaural is exactly right, probably an early type of stereo transmission. Great story about that. And it's actually just a story that I read about probably for the first time maybe about 6 months ago.
Wow. Yeah, that is, it's
just when you think you know when something started, it just went back another 20 years.
Exactly. Like, same thing with photographs, too. It's like, you always think, like, maybe, the 30s or 40s, but it's like 1800s or something.
Yeah.
It's crazy.
I mean, I mean, for years, Alexander Graham Bell was given the credit for like introducing the first transmitter / microphone that actually operated. In fact, he got a patent on it. And I think about 8 or 9 years ago, a consultant that I know was doing some research on Staten Island in this at this museum, and he found these microphones from like 1850 made by a guy named Meucci that were still working.
Oh, no.
And so I'll read things now. It says, Alexander Graham Bell invented the microphone. No, not really. So, maybe there was somebody before Meucci even, and that was 1850.
Right. Oh, my goodness.
Yeah.
Cool. All right, let's get into the myths.
Okay.
A lot of people, well, especially I think with specifications, I think, some people value certain specs of the mics more than others and everything, but it can be sort of confusing. So what are some of the myths there?
Well, first thing you got to be careful about when you compare specs is you got to make sure that they're actually done the same. Sometimes this is done because there's simply no standards. Sometimes this is done because marketing departments try to get tricky.
Yeah.
Sometimes it's done because you've been in business like Shure for 92 years and you don't do it the same as you used to.
Right.
I'll give you one example of that. So for many, many years, we used to test microphones with a sound pressure level going into the microphone of 74 dB SPL, which is 1 microbar of pressure. Why that was chosen, I don't know. It's around standard conversational level, and that was it. So you can go back and look at our microphones from the 30s and the 40s and the 50s, and if the data sheets are written right, it'll say input 1 kilohertz, 74 dB of sound pressure level, or it might say 1 microbar. Okay, that's great. Well, the European Union decided, probably in the late 80s, early 90s, that's really not a good way to test microphones because most microphones are used close to the mouth, right? Mm-hmm. Think about that. And the sound pressure level there is greater. So now they said, well, we want to specify as 94 dB of sound pressure level, which is 10 microbars, or they call it 1 Pascal. Pascal was a researcher, and this was like a term that they wanted to name after him. So now we adopted that, and now our microphones are tested at 94 dB SPL. The problem is that you look at a current SM58 data sheet, and it says its output level is blank at 1 Pascal, and then you go back and you look at an SM58 data sheet from 1970 when we tested it at 74 dB SPL, and you basically make the wrong assumption. Oh, look, the new microphones are 20 dB hotter.
Right.
Wrong.
Right.
We just put 20 dB more into them. So it can be really confusing, even for professionals, when we go back and look at stuff like that.
Right.
It's quite difficult because there isn't any international standard that says, okay, you should do this, and you should do this, and you should do this. Now, there's a lot of things that, one of the things I always like to look at is, on condenser microphones, is self-noise. How much hiss does it present, right, basically. Right. But even that, you can go back, and is it C-weighted, is it A-weighted, there's all these different things. I'd like to be able to tell your listeners there's a really easy way to interpret it. There's really not.
Right.
One of the things we always get asked for, and this is one of my soapboxes, which I always love, is what's the reach of that microphone? How far away could that microphone reach? I hate that term because it makes the assumption that somehow that microphone that's sitting on your desk is reaching out with an arm and grabbing your voice as it comes out of your mouth.
Right.
I always say there's no such thing as a microphone reach. All the microphone does is it measures the sound pressure level that travels to it. You can't reach out and grab something come out of your mouth. And the analogy I make, Chris, is this. Okay, I'm a nature recordist, and I'm going up to record the sound of a wolf howling in Canada. So I go up to the far reaches of Canada, and I'm 100 miles away from any city, and it's completely silent, and there's no wind blowing or anything, and a wolf howls from a half a mile away, and I can record it even though I'm a half a mile away from that wolf just because the background noise is so low,
right.
Okay? So now I take this recording back, and that same wolf now follows me to New York City, gets on the subway,
nice.
And now starts howling a half a mile away when he's in Central Park and I'm on 55th Street, and I can see him howling through my binoculars, and I put that same microphone out the window, and all I get is traffic noise.
Right. That's a great way to put it.
Right? So originally, if you believe the microphone reach, when I was in Canada, that microphone had a reach of a half a mile. But now that I'm in New York City, that same microphone only has a reach of 10 feet.
Right.
Nothing changed.
Totally.
So that's why the term reach is really completely useless.
You reminded me of one thing. I hear podcasters sometimes say that, ooh, I had my mic preamp cranked too high. I was hearing too much background noise. So I turned down the mic pre so the background noise would be turned down.
No.
And so that person doesn't understand that it doesn't work like that. It doesn't work like that.
There's a colleague of mine that has a great term. We often call microphones directional. He says we should really call them rejectional. Because they don't have the ability to listen more in one direction. They have the ability to not listen so well in different directions. So they can reject sounds coming from the back or the sides, but if a sound's coming from the front and that sound is the sound you want is mixed in with other sound you don't want coming from the front of the microphone, it can't sort it out.
Right.
Because all it does is it measures air movement, and all that air movement is just mixed up together.
Right.
You can't, your brain can sort it out because your brain is truly amazing, but the microphone can't. I always like to say microphones are stupid.
Yeah, right?
Yeah.
If
the air moves, they pick it up, and they don't care what caused that air to move in the first place. They have no interest in that.
Right. And if there's background noise and there's a person speaking in the foreground, the mic can't distinguish between background noise or a person or a cymbal or a guitar.
Yep. And so, we get this all the time. And they say, yeah, but I saw it in the movies. I said, but what you see in the movies is not done. It's all done post-production. One of the greatest things I ever saw. This was early on when Raiders of the Lost Ark first came out, and that was I think in the 70s, right?
Maybe 81, something like that.
Yeah, and I went to see a guy who was actually on the audio production of it, and he did this presentation at I think it was the AES, Acoustical Audio Engineering Society, and he said, "I'm going to show you the famous scene where the Rock is chasing down." Indiana Jones, and I'm going to let you hear what actually was recorded. And it was, you hear people talking in the background, and there's all this noise and so forth. And what he eventually came away with, I learned, is that for Star Wars, Raiders of the Lost Ark, 95% of what we hear is post-production.
Right. Yeah, totally. Yeah. I mean, now they replace almost all the dialogue in all movies. Right.
So I tell people, if you're learning about audio by watching movies, you're being completely bamboozled. It doesn't work like that.
Totally. All right. What other any last myth or any other thing that people get wrong?
Yeah, you cannot distort. We kind of touched on this before. You cannot distort a dynamic microphone, a well-made dynamic microphone. No human can scream loud enough to make that microphone distort. You'll distort the next thing, like you said, the preamp, and that basically blowing into it or banging a microphone won't damage it either. I mean, assuming it's a well-made microphone, that won't be the case.
Got it.
Cheap ones, I can't talk about that.
Right. Yeah, that's a different ballgame.
But and there's the whole thing about saying, a condenser microphone is better than a dynamic microphone. You can't talk about that. It's like saying a screwdriver is better than a hammer.
Oh, that's good.
Right. I mean, it's a tool, and you got to choose the tools based upon
the work,
what the application is exactly. Yeah. The thing I also tell people who are first getting into it, if you can buy like a Shure SM58, and if you treat it well, you're never going to have to buy another one for your entire life.
Exactly.
I mean, I bought my first Shure microphone when I was in high school, and I still have it, and it still works fine. We've got microphones, Chris, that we built for World War II, for like fighter pilots and tanks and so forth, and they all still work.
Wow.
So if you buy a high quality microphone and you take care of it, you're never going to need another one.
That reminds me, I saw this one thing, I think it was a documentary on World War II about Germany, how Germany, they created a microphone because the tanks were so loud and they were having trouble like from one tank talking to the next tank.
Oh, I bet.
With a regular mic. So they developed this thing. It's almost like these little things that are pressed up against your throat.
Oh, yeah. Throat mics. Yeah, we made them. We made them for fighter pilots. Well, basically, what they were carbon elements. We talked about carbon earlier before, and they basically you would press them up against your vocal cords, and they would measure the vibrations of your throat, your vocal cords, and so consequently, they were very unsusceptible to airborne noise, but they were pretty good at picking up vibrational noise. And so they worked pretty well for that. I mean, it wasn't the greatest fidelity, but at least you had some ability to hear something because the signal to noise ratio was greatly improved. Believe it or not, Chris, we have those throat mics. We have them even new in the box from like 1944, 1945.
Really?
Yeah.
And so you must not get a lot of high end from the throat. It must be mostly low end and some mid range.
It is, but it's intelligible. And what they did was they rolled off the low end electronically. There was ways to do that. So you got a lot of mid frequencies, but it was enough to hear what's going on.
Right.
We actually have, just might be of interest to your listeners, we actually have an archive here at Shure that I'm responsible for, along with our archivist. And we have nearly one of every product we've made since 1933.
Oh, my goodness.
Yeah. And that it's useful for historical things, for articles and so forth. But really what's kind of interesting is we go back and we take design ideas and things as far as how microphones look from the 30s and the 40s and the 50s, and we reuse them. And so it's really a great way to kind of recycle ideas and designs.
Right. You know, I have some ideas for designs just in terms of podcasting and like really amateur audio. And also partly because sometimes you'll go to a department store and all the workers will have the little headset on with the mic, and they'll be like they'll be able to talk to each other. And I think and you know, they're kind of some, again, this is all not professional. This is consumer level.
Yeah, I understand.
But you know, there's got to be a way, because what I wanted, I host a show called The Mystic Show. Okay. And a lot of time I'm talking to people about meditation and spirituality, and we'll have the best conversation for like an hour, and I'll be like, oh my God, I should have recorded that. Yeah. And like, so I wish I just had a mic on me, like at all times, that was literally recording. Just for me, you know, I don't want to record other people. But then I'm like, well, where do you put that? Do you put it in your ear? Like they make the little Bluetooth earpieces, but I don't want anything in my ear. Do you make it as a, you know, part of your eyeglasses? I don't wear glasses. Am I going to wear a lav all the time? No way. So I'm like, how can you put a mic on people that's just there? And then of course, if you could link it Bluetooth to different, you know, your phone and stuff, that'd be awesome. And then if you had 5 people in a room, you could have one device that's like a Bluetooth recorder where all the 5 mics are connected Bluetooth to the one recorder, and it records all 5 separately. Yep. Yeah.
But again, you know, going back to mics are stupid, right? You could be in that room. For example, you might have a great conversation with 5 people, and it was at a bar. Right. And your brain, with binaural hearing and everything like that, you sorted out and you heard everything that was being said. And then you go back and listen to it for Mike, and all you hear is background noise.
Right. That's true. Totally true.
You know, I mean, the human hearing mechanism is just nothing short of amazing to be able to sort out what's going on. I once had an analogy like this. Someone asked me this question, and this is a little bit off topic because it's about wireless microphones. Well, I got this wireless microphone, and it works absolutely great when I'm in Podunk, Illinois. But you know, when I take it to New York City, it can hardly transmit, you know, 10 feet. What's wrong with your microphone, right? Nice. And I said, well, I tell you what. Let's imagine you're going to a party, and you're the first one to show up, and you're sitting in the living room, and the hostess is 20 feet away or 30 feet away in the kitchen, and you're having a conversation, you know, right. And you're listening. And this is great. Now, 2 hours later, the place is filled with people, and now you got to be 6 inches away from that hostess to understand what's being said.
Right.
What's wrong with your hearing?
Exactly. What's wrong with your hearing?
Nothing's wrong. It's now all of a sudden. At first, the signal to noise, what you wanted to hear versus everything else, was really, really great. There was no noise. You could hear properly. And then it fills up with people, and now you've got basically horrible signal to noise. Now, you can sort out, you know, that's called the cocktail party effect. You can sort out with your brain what's being said if you really concentrate, but microphones, nope. All you'd hear is...
Right. Well, and that's probably because of the visual element. When you can look at someone and look at their lips...
Yes.
Yeah. Okay.
That helps you as well. There's a lot of things going on there that visual, like you said, the 2 ears, the slight difference of the ears and how they're split. A lot of stuff going on. But microphones, they can't do that. So you may be disappointed with what you get.
Right? Yeah. Well, anyway, it's a dream for now. I have many dreams like this, but anyway. So this is great. I can't wait to check out the Shure, the KSM SM353 and the KSM 313.
Yeah, there's something, man.
The Roswellite ribbon technology.
Your friend Mary, I think WFMT just got a KSM 313 not too long ago. You might want to check and see what she thinks of it.
Really? All right, cool.
Yeah.
And when she was on this show previously, I think she was speaking to. I think she had a Shure USB mic. I think it was like a.
Yes, we actually make some USB mics. Yep.
Okay, because she sounded good.
Yeah, we make 2 mics that go into USB, and we make a mid-side microphone that goes into iPhones, which have a lightning connector on them.
Wow, a mid-side mic for iPhones with a lightning connector. Okay.
We didn't even get it into stereo recording in mid-side. That's a whole nother thing. But yes.
Oh, and you know what else I got? Oh, wait, hold on one second. I got to reach right over here and get. Oh, reached all the way over the mixer. My headphone cord got caught on the mixer. No, I was just I don't know how I got a mic. I got an email from someone at Shure, and they said, "Hey, do you want to answer a few questions?" And I was like, "Okay." And so I answered a few questions. I think it was mainly about podcast recording, because it makes sense. And then they're like, "Oh, we'll send you a Shure. It's called a MVL. It's a
little lav with a tip ring sleeve lav that goes into iPhones. Yep."
Yeah, it's a lavalier condenser microphone for iOS and Android, and it's a little lavalier, just plugs right into your phone. And I tried it out. It's really good. I mean, it's just nice. I think it's an Omni.
It is.
Yeah, it's an Omni. Yep, it's Omni, which, I don't know, I kind of go back. I don't use a lot of lavs, but I kind of go back and forth sometimes with lavs. I'm like, because Omni obviously picks up everything from all directions. So right. In my purist mindset, I want something that's directional. But
the problem with Omnis is that so many of them are put on by people who don't know what they're doing. My turn to talk now, and he puts it on. And so we find that directional Omnis get put on sideways, put on upside down. Directional Omnis are
directional lavs, yeah.
I'm sorry. Directional lavs, sorry. Yeah. Directional lavs are more susceptible to wind noise. They're more susceptible to handling noise. They're more susceptible to touching noise. They got lots of problems, and it has to do with physics. So as a general rule, I always recommend omnidirectional lavs, unless you're in a situation where you have gain before feedback. You're trying to use it for a PA system, and lavs really don't work good for PA systems no matter what.
Right? Yeah. I wouldn't even try that actually. That just doesn't sound like it would work.
No, it's hard to do. I mean, lavs go back to originally they were designed for television newscasters and so forth. And people say, "Oh, they're small. I really like them. I'm going to try to use them for all types of purposes that don't work well." What I really like, for people, if you're going to be doing presentations, use a head-worn mic, right? Puts the microphone an inch away from your mouth. You got lots of gain before feedback. You can look up, you can look down, you can look sideways, you can look left, and the gain stays the same. And boy, I tell you, nothing like a head-worn mic for consistent audio.
Yeah, and most of those head-worn ones, or the expensive ones that are really thin and stuff, those are also Omni.
Yeah, that's correct.
Yeah,
and they work for gain before feedback because they're so close to the mouth.
Right, they're close to the source, so the ratio of source to background noise is.
That's right, man.
Great.
Here we go back to signal and noise and basic physics. It's always going to be there.
Right. This is awesome. Well, Michael, thank you so much for coming on the show, man.
You're welcome, Chris. It was enjoyable.
Yeah, we'll hang again soon. Michael Pettersen, Director of Corporate History at Shure Incorporated in Chicago. And, next time I come to Chicago, me, you, and Mary are going to have to hang out, and we'll go into the Shure archive room and check out everything.
We could certainly do that. Just give me a couple weeks' notice and to organize it, and we can do it.
That would be so cool. I'd have to bring my video camera or even record audio, of course, for this show. I mean, come on.
We could. Yeah, there are certain areas, we can't let you into where we develop products, but the archives, we can allow that there.
Well, you never know, Michael. Maybe you'll be able to get me a little laminate with a little, little security permission. I don't know. Anyway, thanks again, Michael.
You're welcome, Chris.
All right, be good, everybody. Thank you for listening. This was awesome. Check out podcastengineeringschool.com for everything else. And until next time, sound great!
Walk away from me well, and you can play that part so well. Why do you play it out on me now? You like to lose control well, it's quite a feeling, isn't it? They're floating, drifting down now. You tell me that you found something better. How should I respond to that? It's a lie. I don't wanna hear it. What do you want me to say? It's a lie. I don't wanna hear it. You react so angry. You change your attitude well. You say I just don't get it now. You say your eyes so far away now. Give up on me, well, so change your